Hello, everybody. This is Manu from Codity Software. I'm here with Carlos.
Hello.
We are going to start the webinar. This webinar is oriented in order to help you to evaluate Plastic SCM. So basically, we will walk through the installation of Plastic. We will let you know how to create your first check-ins. We will check what the branch explorer is and how to get the benefit and the maximum benefit of using the branch explorer. We are going to also be covering the merge system of Plastic SCM. We are going to be generating a couple of conflicts and reviewing how to solve them using the merge engine. And finally, we are going to explain how the distributed development work with Plastic SCM, how you can pull and push changes from your local repository and your local server to the Plastic SCM cloud, for example. And some of the attendees, we know they are in the game industry. So we are going to be also covering our artist GUI that is called Gluon. We are going to check how you can work with a minimalistic graphical user interface that will help your artist to use a version control system. So let's start.
Before we start, just for you to know that you can stop Manu. You have any question, I will be monitoring the questions. So
yeah.
If you need something with more details or something more explanations, just let us know.
That's right.
Okay?
Yeah, you have the ability to raise your hand using the GoToMeeting or GoToWebinar tool, and you are free to, even if you want, you can talk with us if you want. If not, you have the chat, and you can write all your questions there. So why Plastic SCM? Well, Plastic SCM is a good choice for you. It's a distributed version control system. It means that you can have centralized and distributed scenarios at the same time in your organization. You can work as the old school version control systems in a centralized way where all your developers are going to be working with your central server, maybe at your office. And on the other hand, you can allow distributed developers to work with their own Plastic SCM server, a really small, lightweight server that will allow them to carry all the history and all the source code with the computer. It's a desktop and a cloud solution. As I said, you can work with your local server, a desktop server, and you can also work with a cloud server. We have something that is called the Plastic SCM Cloud, and you can store your repositories in the cloud using our own cloud solution. You can do agile development using the branch per task methodology. The branch per task methodology or strategy is really good for agile. Creating branches is super cheap in Plastic SCM. You don't have to worry about how the server is going to behave when it has thousands of branches. It will do it just fine. So creating branches and merging is super easy with Plastic SCM. It's also Game Studios friendly. We have, as I said, the Gluon interface. It will allow the artist to download only certain assets to the workspace. It's not mandatory to download the entire repository to your workspace, so you can focus on the files you will be working with. Then we have big asset file support. That means that it doesn't matter how big your files are, you can submit them to the Plastic SCM repository. It's not going to behave slowly or slower once you commit big files. We have no limitation on that. And finally, it's really easy to use. This webinar is going to help you to understand the basic concepts, and as I said, we will walk through the installation to the distributed development. So the evolution topics are the ones we already talked. First, installation and configuration, the first check-ins, the branch explorer, merge system, distributed development, and Gluon. You can, as Carlos said, you can interrupt us, you can stop me, and ask whatever you want regarding plastic and Gluon. If there's a scenario you want me to cover, I will be more than happy to support that, and we can, you know, make the webinar fits your interest in plastic. So let's jump to my desktop, because here I have the Plastic SCM installer. As I said, we are going to start from the beginning, and that's installing Plastic SCM on the computer. It doesn't matter if it's a Plastic SCM server or a Plastic SCM client. The installation is much more or less the same in both scenarios. Of course, here I'm choosing Windows as my platform. For Linux, just let you know, we have native packages. So, for example, you can use apt-get or zipper for your Linux distribution. Okay, so let's go through the installer. It's really simple. Here you have to select where you want to put your installation. This is a full installer, so it has the server component and also the client component, which includes Gluon by default. So let's choose just the server and the client. And the next question is, what GUI are you going to be using after installing plastic, the regular GUI or Gluon? In my case, I'm going to start using the regular GUI, so let's go with that and install that in my computer. It's really fast and really simple to get plastic installed, as I said. Okay, so let's configure the Plastic SCM server and start it. Configuring the server is really simple. The first question the installer is asking us is which type of server are you installing or license are you installing, the Team Edition or the Enterprise Edition. This is just for evaluation purposes. So if you are going to be using SQL Server, you will need to jump into Enterprise Edition. And also, if you are going to be using the LDAP support for the authentication, you will need to go for the Enterprise Edition. Otherwise, the Team Edition will do it. Okay. Let's go to for the Team Edition. 8087 is our default port. You can change it here. Local name is good for evaluation purposes on your local machine, but not for evaluation purposes on an enterprise. For an enterprise, I will jump into users and passwords. It will ask us for creating a couple of users. In this case, I'm going to use Manu as the password as well. And that's all. You are able to create groups if you want. I'm not going to be creating groups right now, just my username. The database backend is by default configured to use Jet, which is our brand new database backend. It's a file system backend. It's extremely fast. It performs better than MySQL and even SQL Server. It doesn't matter if you use it for a single developer or thousands of developers. Jet will perform extremely fine. I do recommend you Jet, and we will be more than happy to hear from you and get feedback from this Jet backend. Sorry. And the license, well, you can configure a different license here if you want. Right now, I'm going to go forward with the Team Edition license the evaluation installer is providing. So let's go. This is just for purchasing a license. I'm going to stick with the evaluation one. And now the server is starting on the background. Once the server starts, the Plastic SCM client wizard starts. This is the client wizard. As you can see, a server has been detected. Localhost 8087. I can check my connection, and it requests me to enter my username and my password. So let me write it and check it. Okay, so everything seems to be working fine. My server is working. My client is able to connect with my server. If you are evaluating plastic and you face connectivity issues, maybe you can check your firewall rules or your antivirus software. Sometimes they will prevent our connections from the client to the server. That's something you will need to check. Otherwise, if you don't get any error, just skip it. What I want to do, I want to start a new project, or do I want to join an existing project? I'm going to join the default one. When the server starts for the very first time, the default repository is created. Of course, right now I'm using my localhost 8087 server, but if you are evaluating and your Plastic SCM server is on a different brand, on a different machine, during the client wizard, you just need to type the server address and the port. That's all. The rest is exactly the same. So let's go for this default repository. I'm going to give the name default also. I don't want to use this path. I want to use this other location, okay? Because I have one project here that I would like to add to Plastic SCM in order to populate this brand new repository. So let's paste this path and proceed. Okay, so this is the very first time I start the Plastic SCM win. It's giving us a warning regarding the license. It will expire in 4 days. You can sign up to our website in order to get another 30 days for free, and also we will be more than happy to provide you with a bigger trial license, an extended one if you need it. Okay, so right now, we have the server set up, we have the client set up. The client is able to get in touch with the server. The next step is adding some source code to the repository. Let me open the Branch Explorer so you can see right now our Branch Explorer is completely empty. Well, it only has this first change set, which is actually the 0 change set. Let me open the options. You can see that this is the 0 change set, and that means the repository is completely empty. We have to populate the repository with content. This is our main branch, and this is our 0 change set. The house icon represents where your workspace is working. In this case, it's just working with the empty repository. We will see that after creating new changes, the house icon will move from this change set to the next one we are going to be creating just now. So let's go to the items view. If I want to add the following content to my repository, I just need to right-click and select Add Directory Tree to Source Control. As you can see, the status for all my files and directories is private. That means that the files are not in the repository yet. Plastic SCM is not tracking those files. That means that if I remove a file, I cannot recover it because the file is only my workspace. It's not in the repository yet. So let's add this content to the repository. As I said, right-click the root item and add directory tree to source control. Okay, now the status has changed. Now it's not private anymore. It's control/check it out. That means that Plastic knows about those files, but they are not in the repository yet. They are just marked as candidates to check in to the repository. So let's go to the pending changes view. We have well, almost 700 items to be added, and this will be my initial check-in. It's always a good practice to enter a check-in comment. You can click this button in order to go through your comments history if you want to reuse them. You can also configure this view to automatically add the timestamp or the owner for every single comment and check-in operation you do. Let's go ahead and check in the content to the repository. Okay, so that's it. Okay, the content now it's in our local repository, and as you can see, now we have a new brand change it. If you check the content, it's having our comment, and if I double click it, you will see all the 691 changes I submit to the repository. Okay, so that's our initial check-in. I would like to change now some of the files and run another check-in. So you will see how you can create more and more changes in your local or the central repository. Let's go to the items view. And well, Plastic, it's having something really cool that is called, we call it transparent SCM. And basically, it allows you to do any refactor you can imagine and then open the pending changes view, and you will see all the changes grouped in that view. You can use the Windows Explorer. You can use your favorite IDE, Eclipse, Visual Studio, without using any Plastic SCM plugins, just modifying the files themselves, and Plastic will be able to check them and track them. So let's go to this WinQuake repository. So for example, let me move this .h file. Let's cut it and paste it somewhere else. So for example, let's paste it inside CMD Runner. I would like to paste it here. And if I go back to Plastic, to the pending changes view, you will see how this item is now considered as a move operation. We didn't tell Plastic that we were moving this file. Plastic is able to track them without telling Plastic a thing. It's really smart. So let's go and modify this .h file. In this case, well, just let's remove this value, okay? Save it, close it, and now let's check what happens. Okay, so the diffs, it's able to show us that the content is now different, and of course, we'll track all different kind of operations. So for example, for this other file, let me move this method from the very top to the bottom. Okay. Let me try to format this. Okay, and let's also change this. Return null, for example. Okay, now if we go back to the pending changes view and refresh, we can check that we have our move item and also a new one, a change item. Well, we are having the differences here. We can check the differences in a text mode or in a semantic mode. If you click semantic, Plastic will be able to read the file and identify that this interface, this method, has been moved from the very top to the bottom. So let's sync the code And well, there are no other differences than the move code. Okay, but we also have a method that has changed. We have this. Okay, this is really cool. This is what we call semantic diff, and you are able to check the differences in a semantic way, not in a text-based way. You can run even a visual diff, so you can understand that this method has been moved to the bottom of the file, and this has been changed. Okay. Well, this is really cool. It's really useful when you are having tons of changes in your files. The semantic diff is really, really cool. Okay, just for you to know, you can go back to the test view, and the differences will be the regular ones. Okay, so let's go and commit or check in this file. Okay, so this is a small refactor. As I said, you're having all the comments stored here, okay, just in case you want to reuse them. Let's check in, and we are missing this move file. Let's check in as an independent check-in. This is going to be a move operation. Okay, so now how the branch explorer looks like. Now we are having extra change sets. If you can remember, the first one was the initial check-in operation, where we added almost 700 items. The second one is the one we just did, just for the change item. And notice the semantic diffs are also present in here while we are diffing a change set. And finally, the last change set is the one we move. If you remember, we also changed the content, so that's why the diff is opening. Okay. So notice how the branch explorer is now rendering the house icon at the end of the branch. That means our house icon, our workspace, is working with the latest changes on the main branch. If we create a branch, which is something I want to do right now, you will see if I switch my workspace to the new branch, the house icon will as well be moving from the main branch to the new branch. So let's right-click the base. You can create new branches from change sets. You can create new branches from labels or from branches. So let's right-click it, create a child branch, and choose a name for your new branch. You can create branches in a manual way. That means you choose the branch name you want to use, and you can also create new branches from task. If you are having Plastic SCM configured to use an issue tracking system, for example, Jira, you will be able to fetch the Jira branches, assign it to you, and you can create new branches from task. This is extremely useful if you are going to follow the branch per task methodology. In this case, I'm not having any issue tracking system configured, so let's go with the manual creation, SCM 001. And you can add some comments, fix a memory leak, and you can use the checkbox. It's really useful for auto-switching your workspace to the new branch. This is really simple. After creating the new branch, switch my workspace to it. And you can check how the house icon is not anymore in the main branch. Now it's in my task branch, in the child branch. That means that I'm working right now completely isolated from main. Every single check-in I'm going to be committing right now will be created in the child branch. So let's go to the Entities view or to the Windows Explorer. Let's continue using the transparent SCM. So for example, let's remove this launch command file, go to the pending changes view, and Plastic knows that this item is not there anymore, has been deleted. So not needed. Let's check in. Perfect. And now the branch explorer will have our child branch with a change set inside. Okay, let's do another change, a really small one. Of course, you can, instead of using the Windows Explorer, you can also use the Plastic SCM GUI. You can even use the checkout, edit, check-in workflow if you want. This is really useful when you are using the exclusive checkout functionality of Plastic SCM. It allows you to lock a file, and anyone else will be able, no one else will be able to edit or check out that file at the same time. He will need to wait until the lock is released. Okay, so let's go and change this content. Well, this is a README. Let's check add this. Okay, real small change. Okay, in order to create a new change set. Dummy change. Check in. Okay, so now our branch explorer is having more content. The next operation I want to perform is merging this branch into main. Okay, so that's really simple in Plastic SCM. You have several alternatives. The first one is, of course, using the merge operation that consists in switching your workspace to the destination branch. Destination branch is going to be main because I want the result of the merge in the main branch. That's why it's the destination. And now I can select this branch and choose merge from this branch. As I said, there are several other ways, and they are inside the advanced merge option. It will allow you to cherry pick this branch and also to merge this branch too. This is really useful in order to automatize operations in Plastic. The merge to operation will allow you to merge branches without having to switch your workspace to the destination, but it has a limitation. It will only allow you to merge to a branch if the content of the branch is not in conflict with your branch. That means if there are conflicts, it will prevent the merge to operation. That's something you will need to change. It's really cool. It's really useful. Right now, we are going to just use the regular merge operation. So I'm already switched to the destination branch. So let's choose merge from this branch. And you can check what we did in the branch. Now they are transformed into merge candidates. We have the change item and we also have the deleted item. Those are the only changes we are having. If you don't understand what's going on, why we are getting these merge candidates, you can always click in this explain merge button, and Plastic will explain you the contributors. We have the source, which is this one, the destination, and the base, which is this change set in here. Okay, and this virtual change set represents the result of the merge. Okay, so let's go and move forward and process the merge. I don't expect any conflict in here because we didn't modify main at the same time. We're going to be doing that in a moment. So let's process all the merge. Okay, that's done. Let's go to the pending changes view, and you will see that we are having, let me make this smaller, so you can see the change item and the deleted item. The items after a merge, the items remain checked out. You will need to commit or check in those items after the merge in order to let you test the merge result. That means that after a merge, you are still free to debug, to compile your source code, and if something went wrong or you are not happy with the merge result because, I don't know, maybe the task code is not good enough, or it's not working fine for you, or your unitary or your integration test have failed, you have the chance of undoing the merge, okay, as I'm doing right now. Undoing the merge will remove all your workspace changes, and you you are as you were before the merge. Let me repeat it in a moment. Merge from this branch, process all the merge. I run all my unitary tests, integration tests, and if everything goes fine, okay, merge, done. And check in. So now our branch explorer is having a new item, it's having a new change set, and also an arrow. This green arrow represents the merge operation. It represents this branch is completely merged into the main branch. Okay, so let's jump into a more difficult merge operation. You will see how easy it is to resolve it with Plastic. So let's create a new branch, the SCM 002. Let's switch to this workspace. Let's switch my workspace to this new branch, sorry. Okay, now I'm working in here, and let's do a more difficult thing. So let's go and this base runner, okay, let's cut it and paste it in WinQuake directly. Let's now open this file and modify this method. Let's cut it and paste it, for example, here. Okay, and let's change this. Instead of false, it's going to be true, and here, false. Okay, save it and close. Let's go back to the pending changes view. It's able to, well, in here it's not able to identify the move operation because the file is not that big in order to match the differences. So let's go to options. No, sorry. Let's go to the delete item. And, sorry, maybe this. Search matches. Okay, we will need, oh, it's not needed even to decrease the similarity. This is going to be the one. Okay, so now it's tracked as a move operation. Perfect. Let me make this bigger. Don't forget that I move this file from the CMD runner directory to WinQuake, and I also change the content. So let's go and branch content. Check in. Okay, now in the Branch Explorer, I will use the Branch Explorer to switch my workspace back to main. So let's switch to main, and I would like to change the same file. So this base CMD runner, I'm going to cut it and paste it, this time inside properties. Okay, and I'm going to be also modifying this method. So platform ID is now going to be, I don't know, Mac OS, for example. And let me go back to the pending changes view, refresh. Now it's identified correctly the move operation. And let's say this is main branch work. Check in. Okay, so now I'm having changes in both the main branch and the task branch. And both changes are modifying and moving the same file. So let's check what happens when I try to merge this branch into main. Now I'm having conflicts. The first one is a divergent move conflict. Let's check the explanation for this conflict. Plastic explains us that the source contributed has moved the file from CMD runner to WinQuake. On the other hand, the destination has moved the same file from CMD runner to CMD runner properties. Obviously, I'm only allowed to preserve one of the move operations. I'm only able to have this file once in my Windows Explorer, my Windows directory. So I need to choose if I want to preserve the source or the destination. In this case, I'm going to preserve the source. Okay, I'm going to keep the file under WinQuake. instead of properties. Okay, so now the divergent move conflict is resolved. I need now to process the merge for the file content. The beauty of this conflict is that Plastic is able to track the move conflict, and at the same time that the file has been changed inside by both contributors. So let's continue with processing all the merge, and well, we can see for the very first time the merge window. Here we have to go through the conflict, and well, let me jump to this. I'm going to preserve this change. You can select and deselect contributors using these buttons. Okay, so let's remove this and preserve only the other change. Okay, the one already done on source. So let's save and exit. Save and exit. Now the conflict has been resolved. If we go back to the pending changes view, we have the merge resolve pending to be changed. To be submitted. So this is merge done from SCM 002 and check-in. Okay, perfect. So the branch explorer is now having a second merge operation from the child branch to the main branch. And the last action we can do is, for example, labeling these changes as our first release. So let's choose label these changes, change it as baseline 001, and this green circle is what we call a Plastic SCM label. You can use Plastic SCM labels to tag your releases and multiple purposes. Okay, perfect. So that's all. That's how you can merge in Plastic. It's really simple, and even if you create really heavy conflicts like the divergent move, resolving them with Plastic is extremely easy. Let's move now to the distributed workflow. I would like to accent something that you will need to do if you are evaluating Plastic, just to avoid issues in the future, okay? By default, the security in Plastic is completely empty. That means that if you are playing with permissions and you touch something that you shouldn't, for example, removing from the Plastic SCM ACL all the users, that will make your installation completely closed, and not even you will be able to access Plastic again. So it's really important, this thing I'm going to be doing right now, which is setting up an admin user for your Plastic SCM installation. This user will be the root user for Plastic. That means that if you break something, you break security, you will be able always to access Plastic with this root user. In order to set up a root user, an admin user in Plastic, you need to go to your repositories list, right-click, choose repository server permission, the last one, and change the owner of the repository server permission from all users to your user, in this case Manu. Click OK, click Apply, and now Manu is the new admin user of Plastic SCM. Perfect. Okay, that is really simple, but really important to set up an admin user in Plastic. So what I would like to do now is using the Plastic SCM Cloud in order to push this content, the default repository content, into the Plastic SCM Cloud. We are going to be pushing the main branch and these two branches, child branches, into the cloud. It's really simple. The best way I think we have to push content to the cloud is creating a sync view. So if you click Other Actions, you will find Sync Repositories. I'm going to create a new view that is going to be to cloud. That's the name. You can choose your own one. I'm going to add a source repo. It's going to be my default repo. And the destination repository is going to be a Plastic SCM Cloud repository. Of course, here you can choose the Plastic SCM cloud, or if you prefer, you can choose your coworker's computer or your central server computer. Okay. Let me type my cloud ID. Let's search the repositories in there. I need to provide access to the Plastic SCM cloud. It will happen exactly the same for your central server. If you are not having permissions, sorry, not permission. If you're not having access yet to not yours, to the central server, it will ask you for credentials, as the cloud is doing for me right now. My username is my email, and I will type my password. And this is really important or really useful. I will remember my credentials as a connection profile. So the next time I use the cloud, it will remember my credentials. It will avoid me typing my ID and my password over and over again. Okay, so now I'm having several of them, a lot of repositories in my cloud. I will use this kick repository. It's empty. I created it before. So I want to populate this kick repository with my local content, my local repository content. So click OK, expand this node, and you will see that Plastic is able to propose all these changes candidates to be pushed to the cloud, because the cloud is not having this content yet. So how do we push the 3 branches at the same time? You right-click the outgoing changes and select push all changes. Okay, so let's start. And now it's starting. Okay, this is really interesting also. If your Plastic SCM server or your Plastic SCM cloud repository is using encryption, that means the content is encrypted, it will ask you for the password. So let me type it and push it to the cloud. All the content of my local repository is going to be encrypted and sent over the network, and lately stored in the Plastic SCM cloud. Okay, so now it's starting the fetch, calculating what it needs to push, and now it's introducing the data into the Plastic SCM cloud. Okay, it's not very big, 11 megabytes. It might be slower because I'm connected with GoToWebinar, but it's pretty easy and pretty fast. Okay, so now both repositories are up to date. There's nothing else to be pushed or pulled. I'm completely fine. As soon as I go and I change something, for example, let's change this to README, and I generate a new change set, you will see that the sync view will notice this and will propose this new change to be pushed to the cloud. So let's right-click it, push this branch, start. And now my cloud or my central Plastic server will have the change set. So my coworkers can pull that content to their local repositories, or start creating new changes from that if they are directly using the central server. Okay, so that's the very basic of the distributed development. I repeat, if you are having questions regarding this workflow, I will be more than happy to cover all the corners. Okay. Of course, if you are having questions after this webinar, you can write to support@coditasoftware.com for technical issues, and sales@coditasoftware.com for other kind of questions. Okay, licenses and so on. So now let me close Plastic SCM, and let's explain in really fast. Let's explain Gluon, the interface for artists. Actually, I'm not going to be closing Plastic because I think I'm going to be using Gluon directly, working with the Plastic SCM cloud, and you will see now how if we generate changes at the cloud, we will need to pull them back to our local server. So let me open Gluon. Okay, and well, I'm going to create a new workspace. I'm not going to be using this default workspace. Let me create a new one, because actually I'm going to be using the cloud repository, not the local one. So the repository, the server is not going to be localhost. It's going to be my cloud. Let's click refresh. Okay, let's choose Kick, which is the one we used for pushing the data before. And let's go with this content. That's okay. Okay, perfect. So I have this new workspace. Let's open it and explain a little bit of Gluon. Okay, we created Gluon around the artist figure. Okay, well, basically an artist in a game studio will try to avoid downloading all the repository content to the workspace. Why? Because the workspace, the repository content might be extremely huge, and the artist is going to be only modifying a couple of files. So Gluon allows you to configure what do you need to download to your workspace. That is done using this configure button and choosing what do you want to download. In this case, I just want to download this directory, the R directory. Okay, let me type again the encryption because it needs also in order to download content to provide the password. It's something you do only once. Okay. And now I'm able to see the repository content. Okay, so if I'm interested in this art directory but not the source code, it's as simple as selecting art. Okay, you will see how the rest of items remain unchecked. So if I want to download only a few of them, I can start unselecting them. That's also possible. Even if you want, you can just download a single item. This is extremely flexible. So let's go and apply this. Now I have my Gluon workspace working with my cloud repository. You can see that from the bottom of my screen. It's working at the main branch, at the Kick repository, at the cloud organization. Okay, so let's go and I don't know, let's modify this item. Let me check out and let me open it in the Windows Explorer. Okay, so let me edit a really easy change. Okay, I'm not an artist, so let me try to color this eye in red. Okay, well, let me try to do it with this. It's going to be faster, I think. Okay, that will be enough. I'm not really good at drawing. So let's save it and close it. Okay, that's a really small change. Okay, in Gluon, we allow you, as well as in Plastic, by the way, we allow you to div the content of your checked out item. So if we div it with the previous revision, you can see how nicely we allow you to check the changes between two images. We can. This is the onion screen. Is the first one, okay, it goes from the first revision to the second revision slowly as I move this slider, okay. Then we have the side-by-side, the one we saw before, okay, just the parent revision of on the left side, the child revision on the right side. We also have the differences view. With this one, we'll reveal where the difference is. It's really good for working or playing to the 7 differences game. And then we have the swipe, which is similar than the onion screen. It will use this slider to reveal the differences, okay? So we can check what happens. And finally, the properties. It seems that the size now is slightly bigger than the previous revision. Okay, so let's go. And now that I have my check it out item, the next thing is submitting the change to the repository using the check-in operation. So let's go to the check-in changes view. As you can see, the GUI is extremely easy to use. We have the Explore Workspace view, the check-in changes view, and the changes view. That's all. We want to keep it focused on artists and keep it as simple as possible. We have this change to be committed. Angry I added and check-in. Remember that I'm checking this change to the repository, to the cloud repository. So now if I move back to Plastic, now I'm having incoming changes, not outgoing anymore. We are having this 11 angry I added. I can even preview this content before downloading it from the cloud, okay, and check the differences. Now, if I want this to be part of my local repository, I need to pull it, and it's as simple as this. Okay, let's wait. Now it finished, and the Branch Explorer, it's having this new change set that is, this new change set, angry I added, and is having the file we just submitted from Gluon through the Plastic SCM cloud. The last view is just change set view. You can review all the change sets created. You can div it, and that's Gluon. Once you finish with this set of files, you can choose if you want to stop loading this content and start loading a different one. It's completely doable. I can unselect or unload this content and start loading just this script, this C# file. And that's what I have, and not the images anymore. Of course, I can reconfigure to get them back, and I will have them in my workspace. So Gluon is super simple to use, is super fast, is really easy, and allows you to download part of the repository, not the full picture. And of course, you can work without having all the content up to date, which is impossible from the Plastic SCM GUI. You are tied to a workspace. Your workspace is tied to a change set. You must be completely updated to this change set if you want to work. Using Gluon, that's not mandatory. Part of your workspace might be up to date. Some of your files may not, and you can continue working as soon as the file you are submitting is the latest one, is the latest revision, because Gluon will not allow you to merge. We keep it simple as possible, as much as possible, and we decided to remove the merge operation from Gluon in order to ease the artist life. Okay, so I think we are reaching the end of the webinar. Right now, well, if you are having questions regarding Plastic, Gluon, or even the Plastic SCM server, we will be more than happy to answer your questions. And well, remember that we are also available for you for technical questions using the support email, which is support@codicesoftware.com, or for sales questions, you can use the sales@codicesoftware.com email. So let's check if we are having questions.
Okay, it seems that there are some questions. Can you explain a little bit more the other action panel, especially the self operation, because I'm not sure how it works?
Yes, you are meaning for I guess from plastic, right? Or
yeah, I think so.
Let's check if we have more information.
Yeah, the regular user interface.
Okay, yeah. So yeah, we have something that is called the self operation. Okay. So far we have been creating new change sets in plastic, but there's another kind of check-in operation which is called self. It allows you to to store some of your local changes in a change set that is not it's not public, at least in the Branch Explorer. Okay, it's a way to save in work, but not in a public way. Let me give you an example. Let me switch my workspace to the head of the branch and modify a source file. For example, this platform identifier file. Okay, so if I do a change in here, let's change this to true, a really simple file change. And if I go to the pending changes view, you will see that the check-in button, it's having this chevron. You can click it and choose self pending changes. Okay, creating a self. And I'm able to undo the changes in my workspace. Okay, they are going to be completely safe inside a self. Okay, a self has been created. Perfect. If I go back to the Branch Explorer, you will see that we are not having more changes created. This last one is the Angry AI change set. Okay, so where is my change? My change is inside a self that is created here. I can review what's inside, and I can choose where to apply the self. So imagine that I was working on the branch incorrectly. I'm not allowed to work on the main branch. I should put that self in a child branch. So let me switch to this to the child branch and apply the self. Okay, applying a self is really similar to a merge operation. You will see it right now. Apply the self in my workspace, process all the merge. Okay, and now I have the change in my workspace. We do a merge operation because the self changes can be applied to any branch or any change set in your system, and maybe the self changes are in conflict with the destination. That's why we run a merge operation, in order to combine the two changes. In this case, there are no conflicts and just the true change created. So let's check in. And now, well, now I'm having a new change set. Okay, the self is still there if you want to reapply it somewhere else. Okay.
Okay, it seems there is one more question.
Okay.
Regarding the exclusive checkout, how can I configure custom rules?
Okay, yeah, it's really simple. We have documentation for that, but let me try to summarize what you need to do. As you may know, the exclusive checkout is a type of checkout that prevents extra developers to modify the file you are working on. That means, for example, if I right-click, if I right-click and I check out this file, if I'm having a rule matching this file or the C# files, that means that I'm the only one allowed to modify this file in this moment, okay? After committing, after checking this file, I will release the lock, and my coworkers will be able to get my revision and continue modifying the file. But without the exclusive checkout, everybody is able to check out at the same time. So in order to configure it, you just need to create a lock.com file in your Plastic SCM server. In Windows, for Windows by default, is inside the program files Plastic SCM5 server, and you will need to create a lock.com file. For sure, I'm not able because of permissions. Okay, a new lock.com file, and you can write the rules inside this file. I can provide you the link, the documentation link, where it explains what kind of rules you can specify for the lock.com file. Okay. Notice that after creating the rules, you will need to restart the Plastic SCM server.
Okay. It seems that there are not more questions.
Okay. So as we said before, please, if you are having questions, don't hesitate to contact us. We will be more than happy to help you to start with Plastic SCM. And also, if there is something you want us to cover in advance, well, let us know it. We will be happy to do that as well. I will remember the email for technical questions, which is support@codicesoftware.com. You will be able to find them in our website just in case. And the sales questions must be sent to sales@codicesoftware.com. Okay, that's all. Thank you very much for attending to this webinar.
Yeah, you are very welcome. You have any questions, as Manu said, and we will be more than happy to assist you.
Okay, thank you very much.
Bye.
See you. Enjoy plastic. Goodbye.